Please confirm if you can hear me clearly and also see my screen. Yes. Okay. Thank you. All right. Let's start then. So this is our next topic, functions. We are done with binomial expansion, coordinate geometry, including equation of circle, and then quadratics, trigonometry, differentiation, integration. So we are done with most of paper one. Uh, Functions is the last major topic as far as the difficulty level is concerned, the difficult topics are concerned, because the other two topics, they're relatively straightforward, circular measure and APGP. So this is the last topic that's actually difficult, functions, and it's probably the most difficult one of paper one, and it's going to take us some time to complete this, maybe around 2.5 to 3 weeks, because there's quite some content that we need to cover in this. So we'll have functions in this and also function transformations. Now, what are functions? This is something that you have some familiarity with from O levels as well. You've done function notation at least in O levels. Let's suppose you have an equation like this, y equals minus 3x plus 7. Now, this is a straight line function. We have dealt with these functions in coordinate geometry as well in paper one. Now, it's a straight line function. If you input some value of x here, for example, if I input x equal to 1, that gives me y equal to minus 3 into 1 plus 7, and that gives me y equal to 4. So when x is equal to 1, this equation gives me y equal to 4. If I have another value of x, for example, if I have x equal to negative 3 or negative 4, that gives me y equal to minus 3 into minus 4 plus 7, and that gives me 12 plus 7, which is 17. Or no, 12 plus 7, that's 19. So that gives me another value for y for x. And similarly, if I input different values of x in this function, I'll get different values of y from that. Now, this same equation, I can write in function notation as well. Okay. Now, what would that look like? I can say this thing y is a function of x. That means it's defined in terms of x. Okay. It's defined in terms of x. And the notation that we use for that is f of x equal to, for the same function, minus 3x plus 7. So f of x, what does it mean? It means function of x. F is a function of x, and it's defined like this, minus 3x plus 7. Okay? This is another way to write that same equation. So it's the same thing, just written in a different way. Okay, it's just a different notation that we've got. Now, in that earlier notation, if we had to input some value of x and get some corresponding value of y, we used to do it like this. We would say input some value of x, so put x equal to 1, we get a corresponding value of y from that. Input this value of x, get a corresponding value of y from that. In function notation, those same things can also be written as, if we have f of x equals minus 3x plus 4 and you want to input x equal to 1 in that, the way to do this would be, you would say find f of 1. So in place of x in this function, you input 1. So f of 1, what is this going to be equal to? Minus 3 into 1 plus 7, and that simplifies to 4. So f of 1 equals 4. What this means is when the value of x is equal to 1, the function value, which is the y value, that is equal to 4. Similarly, if I say, let's evaluate f of minus 4 from this, what does that mean? Wherever you have x in this function, you replace that with minus 4. So that gives you minus 3 into minus 4 plus 7. And that's 12 plus 7, which is 19. So f of minus 4 equals 19. What that means is, if I were to input x equal to minus 4 in this function, the corresponding value of y that I get from that is 19. So this is another way to write that same equation. Okay. Now this function notation can be used for numbers that you input 1 inside this or minus 4 inside this, for instance. You can use this for other expressions in terms of x as well. So if the function is defined like this, I could also find, for instance, f of x squared in this. Now, what would that be? If f of x is equal to minus 3x plus 7, f of x squared, what will that be? I can just replace x in this equation with x squared. So that will become minus 3x squared plus 7. Okay. Similarly, I can find something else as well, like maybe f of 5x plus 2. What would that be? Again, wherever in this expression you have x, you just replace that with 5x plus 2, so it becomes minus 3 outside as it is, into x, replace x with 5x plus 2, and then you have 7 outside added. Simplify this, and that gives you minus 15x minus 6 plus 7, which is minus 15x plus 1. So f of 5x plus 2, given that the function f is defined like this, can be written like this, minus 15x plus 1. Okay, so that's what function notation is. All right. Now, this is something that you know from O-levels as well. All right, there's nothing new here as such. Another thing that you've done in O-levels already, that's how to find inverse of a linear function, inverse of this function, right? You've done that as well. Now we'll talk about that later because we want to talk about inverse of not just linear function now, but we'll be talking about how to find inverse of quadratic functions, inverse of trigonometric functions. So we'll leave that for later. That's another concept that you've done in O-levels, at least for the linear functions. Okay, we'll talk about how to extend that to other kinds of functions as well, how to find inverse of quadratic or trigonometric functions. But in today's class, I want to focus primarily on something that we call the domain and range of functions. Okay, so let's start with that. That's the main concept I want to cover today. Domain and range of different types of functions. Okay. Now let's understand what this is. So we have two terminologies that we'll be using in this topic a lot, and they are domain and range. Now, what do they stand for? What is domain and what is range? Let me write that down here. Domain of a function. Domain of a function is the set of values, of x that a function can take as input. And range stands for the set of values of y that a function can give as an output. So domain stands for the set of values of x that a function can take as an input. And range stands for the set of values of y that a function can give as an output. Now, what does that mean? A function is basically kind of an input-output relation. So this function that I wrote below, before, f of x equals minus 3x plus 7. What exactly does this function do? This thing x is the input that we give to the function. So for example, if I input x equal to 1 in this function, we often represent functions like this using this flowchart, that we have this function f. What happens is something goes to this function as an input. So you can have, for instance, x equals 1 going to this function as an input. This function applies some operation on it. So in this case, what the function does is it multiplies the input by -3. So what it'll do is it'll multiply x by -3, and then it'll add 7 to that. So -3 times 1 plus 7. Once it applies these operations, it gives you an output. And that output is the y value that you get from the function, which in this case is going to be 4. So that's how a function generally works. It takes something as an input, it applies some operations on it. In this case, it's multiplying by -3 and it's adding 7 to it. And then it gives you an output. Okay, that's how a function works. So what are domain and range of a function? Domain is the values of x that a function can take as an input, and range is the values of y that a function can give as an output. All right. Now, what do we need to know about domain and range? Let's talk about both of them one by one. Let's start with domain first of all. Let's start with domain. Let's suppose I have a function that looks like this. I have a function like this, f of x equal to 2 into square root of x plus 3. I have this function. It's defined like this. Now, is there any restriction on the values of x that I can input in this function? Can I just input any value of x in this, or is there any restriction on this? Is there any restriction on the values of x that I can input in this function? What do you think? Can I input just any value of x in this? Can I input just any value of x in this? It must be greater than -3 or less than 3. Okay. If I input any value of x in this function such that this expression inside the square root becomes negative, this function would not give me any result, right? Because square root of negative numbers, generally in real numbers, it does not exist, right? So the part inside the square root, it cannot be negative. So what that means is x plus 3, this whole expression inside the square root, it must be greater than or equal to 0. It can be equal to 0. That's possible. Square root of 0 is just 0. However, it cannot be negative. Now, if x plus 3 is greater than or equal to 0, what about x? X must be greater than or equal to -3, right? So the domain that we have for x in this function is greater than or equal to -3. All right. So this function has an inherent limitation that you can only input values of x that are greater than or equal to -3. Okay. What if there was no limitation like this? What if there was no square root? For example, if it's a general linear function, if you have, for example, 5x plus 2, if you have a function like this, it's a general linear function. Now, in this function, in a straight line function, there's no restriction as such. Mathematically, you could input any value of x in this and it would give you some result. You can input negative values, positive values, 0. Any value would exist. Any value would give you a result. So how would you write down the domain of this? There's a notation that we use for this, and that looks like this: x, and then this symbol that you must have seen in sets and O levels, belongs to, and then you have the sign R that stands for real numbers. So x belongs to R. What that means is x is a real number. So it could be any number basically. X is a real number. Real numbers are basically all numbers that you have done until this point: positive, negative, rational, irrational, integers, decimals. All of these are types of real numbers. Okay. There's another category of numbers that we'll study in paper 3 later on, that's called complex numbers. But apart from complex numbers, all the numbers that you know until now, they're all real numbers. Okay. So for this function, mathematically, there's no restriction. You would say its domain is all real numbers. Okay. Let's take another example. Let's say I have a function like this. Let me use another letter now. So I can also have some other letter apart from f here. Let's suppose g. Let's say I have a function g of x, and that looks like this. G of x is equal to 3 over 2x plus 4. I have this function. Now, do you think there's any inherent limitation on this function? Can I input just any value of x in this function and the function would give me some result? Or is there any restriction? Would there be any restriction on this function? X cannot equal negative 2? Okay. So generally, any value of x should work here, but there's one exception, and that is since you have x in the denominator here, since you've got x in the denominator, whenever you have a variable in the denominator, you've got to be careful that in the denominator you cannot have 0 because division by 0 is not possible, right? That's undefined. So any value in general for x would work in this case, but there's one exception, and that exception is that the denominator cannot be equal to 0, right? Because that will make the function undefined. Now, if 2x plus 4 is not equal to 0, what value of x do you get from that? You can take negative 4 to the other side, that becomes negative 4 divided by 2. And that gives you that x should not be equal to negative 2. So apart from negative 2, any value of x would work in this function. So you could say the domain of this function is x not equal to negative 2. So any real number apart from negative 2 should work in this. Okay? So you can just write x not equal to negative 2. Another way to write this sometimes is that you say x is a real number, but there's one exception that x cannot be equal to negative 2. So it could be any real number, but there's one exception that negative 2 is not possible. All right. Now, as far as domain is concerned, these are the only two restrictions that you need to know about, which are the inherent limitations of a function. Okay, I'm sorry. Inherent limitations of a function, that if you have a square root cannot have a negative value. And if you have a fraction, the denominator cannot equal 0. Okay. All right. Now, most of the times, however, even if you have a function that mathematically can take any input, there will be some practical restrictions on that function, because of which we might have a domain that is not coming from the inherent limitation of the function. Let me give you an example. Let's say I have a function like this, p of x, that equals, or let's suppose q of x that equals 15 minus 2x. I've got this function. Okay. Now, Q represents, let's suppose we're talking about some product, and Q represents the quantity of that product, and X stands for price. So in this case, I'm saying this variable X represents price of something, right? So it could be any commodity that we're talking about, but X stands for price. Now, generally, in practical terms, what happens is price cannot be negative, right? Generally, that does not happen. Since price cannot be negative, and it can't be zero as well, generally, because zero means that you're giving something for free. In rare cases, that could happen, but generally speaking, price is going to be some positive number. So in this case, if there's a practical limitation like this, they can sometimes, or they will most of the times, tell you a domain for that function themselves in the question. Now, it's a linear function. Linear functions we saw above, they can take any input as far as the mathematics of this is concerned, as far as this function itself is concerned, mathematically, any value of x you input, you should get some value for y, some value of the function. However, since there's a practical limitation that x represents price, and price generally cannot be negative, can't be zero as well. In this case, there might be an additional restriction that x should be greater than zero. If there's anything like this, what happens is they give you the domain of the function themselves. And what you have to do is you have to find the range of the function based on that. So most of the problems that you'll see, you would have to find the range of the function given the domain. For domain, as I said, you only need to know what happens in case of square roots and what happens when you have a fraction with x in the denominator. Apart from these two restrictions, for any other restrictions, they will tell you the domain, and you would mostly be looking for the range of the function. So let's talk about range of functions then. Starting with the linear functions first of all. Okay, so we talked about the domain, the two cases that you need to know about. Let's talk about range of functions now, and we'll start with linear functions first of all. Linear functions. Linear function means straight line function. Let's talk about these. Let's say I have a function like this, f of x equal to 3x plus 5. Okay. And I am given that the domain of this function is x greater than or equal to 3. Okay. So this is given in the question. The domain of the function is x greater than or equal to 3. Now, what we want to do is we want to find the range of the function. Range means the values of y that this function can give as an output. Okay. So we've got this function given. They've given us the domain of the function as well. We want to figure out the range of the function, the values of y. Now, how do you do this? How do you find the range of this function? You can see what happens when x is equal to 3, right? You can input x equal to 3 in this and see what value of the function you get from this. So when you input x equal to 3, you get f of 3. What will that be? 3 into 3 plus 5, and that is going to be equal to 14. So that tells you when x is equal to 3, the y value is 14. Okay. Now, based on this, can you say anything about the range of the function? Can you say anything about the range of the function based on this? What should that be? Range means values of y. So domain was x greater than or equal to 3. At 3, the y value is 14. It's a positive gradient line. The range of the function is going to be y greater than or equal to 14. Okay, this is the y value, remember? Now, in this case, it was pretty straightforward. because we just input 3 in this, we got a corresponding value for y, and we had a greater than equal to sign here. We put the greater than equal to sign with the range as well. However, we've got to be careful. And I would generally recommend for finding the range of such functions, you make a rough sketch quickly, and that will save you from careless errors. And you will understand why when we look at the next few examples. So let's try doing it here as well. What does the graph of this function look like? It's f of x equals 3x plus 5. It's a positive gradient line, so it would look something like this. Right? This is what the function is going to look like. F of x equal to 3x plus 5. It's a positive gradient line. They are saying x is greater than or equal to 3. So horizontally, they are saying there is some point on this line when x is equal to 3. The domain of the function is that you have to be to the right of 3. So basically, all the values to the right of this. That's the domain of this function. So on the graph, you can say this is the point where x is equal to 3. This is the point where x is equal to 3. What's the corresponding y value at that point? We put 3 in that function. The corresponding y value turned out to be 14. They have told us the part of the function to the right of this is valid. This is the part where x is greater than or equal to 3. Okay. So this was 3. The part to the right side, this is x greater than or equal to 3. Now, what are the corresponding values of y in this function? Look at the vertical axis. Look at the vertical axis. What's the value at this point on the vertical axis? This is 14. So you've got 14 here. On this axis, what values of y are going to be possible? You have to be above 14, right? So that is why we've got y greater than or equal to 14 in this case. We say all the values above 14 or equal to 14, they satisfy the condition. So on the vertical axis, we can say y is greater than or equal to 14, and that's the range of the function. Okay. Now you might think, is it really necessary? Why are we drawing this graph? Could we just not write down the range directly? Well, let's take another example, and that might help you understand why this is important. Let me write down another function here. Let's say I've got another function g of x, and that is equal to minus 2x plus 3. I've got another linear function. It looks like this. And let's suppose I'm given that the domain of this function is x greater than 4. That's the domain of the function. What I want to figure out is the range of the function. So given the domain x greater than 4, what will be the range of this function? That's what you want to figure out. Okay, what do you think about this? I'll give you 30 seconds to try this. Let me know what the range for this function is going to be. What's the range of this function? So x values have to be greater than 4. What about the y values? The output that we would get from the function, what will be the inequality for that? Greater than minus 4.8, less than minus 7, less than minus 5. Why am I getting so many different results? Okay. So would you guys want to explain what exactly you're trying to do there? Okay, so the first thing that most of you would have thought would be inputting x equal to 4 in this, right? And see what you get from that. Let's start with that. Input x equal to 4 in this function. Okay. What do you get from that? G of 4 equals minus 2 into 4 plus 3, and that gives me negative 5. So that means when x is equal to 4, the y value is negative 5. Okay, so this is where we have our first confusion. The question says, the domain says x is greater than 4. Why are we inputting 4 there? Some of you are suggesting we should be inputting 5 because x is greater than 4. So instead of inputting 4 there, we should be putting in 5. Should we put 5 or 4? It says greater than 4, right? Greater than 4. Is 5 the first value that is greater than 4? Does x necessarily have to be an integer? It doesn't say that, right? It does not have to be an integer necessarily. So greater than 4 could be 4.1 as well. It could be 4.001. It could be 4.0000001, and then 4.00000, and then infinitely many zeros, and then maybe a 1, right? So greater than 4 means something that's only slightly greater than 4. So that means 4.000 and then billions of zeros and then maybe a 1 somewhere. Now, can we input that number? We don't even know what that number is going to be. So what we do is, it's so close to 4, we input 4, okay? And the value that we get from that -5, just like we have a strict inequality here, as in we don't have an equal to sign with this, with the range as well, we would not put an equal to sign with -5, okay? So we will check that same value and then we write down the range. We would not put an equal to sign with -5 as well, and that will exclude this particular point, okay? So you're not going to input 5 in this, you will still input 4, and the inequality sign will take care of that at the end. Okay, that's the first thing. So when we input x equal to 4, the y value that we're getting from this is -5. Now, does that mean the range is going to be y greater than -5 because it has a greater than sign here? Well, not necessarily, because as I said, it's important to check or at least think of how the graph would look like. It's a linear function. However, it's a negative gradient linear function. So what is the line going to look like? It's -2x plus 3, right? So what's the direction of the line going to be? It's going to be a line that goes downwards like this, right? So it'll be a downward sloping line. On this line, there's some point where x is equal to 4. So let's suppose that point is here. X is 4 here. What about the y value? Y value is -5. They are saying x is greater than 4. So which side of this function is being considered in the domain? The right side, x greater than 4. So we are considering the right side of this function. So vertically on the y-axis, this is x greater than 4, right? Vertically on the y-axis, which side of the function is valid? To the right side, we've got this part of the function. Are the y values going down or up? The y values are going down here. So the corresponding y values that we get for this, they are going to be less than -5. So the range is going to be y less than -5 here. And that's what we will write here. The range of this function is going to be y less than -5. So the inequality sign is not necessarily going to be the same. You will have to think of the graph, think of how the graph is going to look like. If it's going downwards, as you go to the right on the x-axis, on the y-axis, you'll actually be going down. So the range will be y less than -5. Does that make sense? Any problems with this? No? Let's take another example. Let's say I have another function now. Let's call that h of x. And that looks like this. Minus 7x plus 2. And the domain of this function is x between -2 and 5. Or let's suppose -3 and 5. So I've got this linear function. I know the domain of the function is x between -2, -3, and 5, with an equal to sign with -3 and no equal to sign with 5. What is the range of this function going to be? I'll give you 30 seconds or a minute to think about this. Let me know the range of the function. Can everyone please respond to this? Range of this function. What is this going to be? Less than 23? You've got a two-sided interval, right? So x is between -3 and 5. So it's a closed interval on both sides. So the range would also look something like this, right? Okay, so how do we think about this? We can look at the end, look at what happens at the endpoints -3 and 5. Let's see what happens at -3, what happens at 5. So let's input x equal to -3. That means h of -3. What would that be? -7 into -3 plus 2. That's 21 plus 2, which is 23. So when x is equal to -3, the y value is 23. That's one point that we brought in the graph. Then there's another point when x is equal to 5. Let's input that, see what happens at that point. X equals 5, that gives us h of 5, which is -7 into 5 plus 2. This value turns out to be -35 plus 2, which is -33. Okay, now let's think of the graph. Let's think of the graph. What does the graph look like? It's a downward sloping curve because the gradient is negative. So the line would look like this: negative slope lines, negative gradient line. We've got 2 points on the line. One is when x is -3 and the other is when x is 5. So -3 is going to be on the left side, 5 is going to be on the right side, right? Let's mark those 2 points. This is 1 point. Let's suppose this is -3 with some y value. What is the y value? 23. And the other one, this is 5 and -33. This is the other point. Okay. Now we have to be between these 2 points. On the x-axis, they're saying it's between -3 and 5. But notice we have an equal to sign with -3, but not with 5. So 5 is not included. -3 is included. 5 is not included. Okay. Now what about the vertical axis? Vertically, what values of y do we get from this? So horizontally, we know we are between -3 and 5, right? So horizontally, we are between -3 and 5. What about vertically? Vertically, we're going from -33 to +23. So this will be the range of the function from -33 to 23. You would say y is between, you have the smaller value on the left side, bigger value on the right side, and you have less than signs like this. You have a closed interval like this from -33 to +23. Okay, that's what the interval is going to look like. But now we need to decide whether to put an equal to sign with any of them. Do we put an equal to sign anywhere in this inequality? Will we have an equal to sign anywhere in this inequality? Do we put the equal to sign on the left side, just like we had it in the domain? No. The domain said -3 is included, right? -3 is included. What is the corresponding y value to -3? It's 23. So for range as well, the equal to sign is going to come with that same point. The y coordinate of that point was 23. So the equal to sign will be on the right side in this case. Since -3 had an equal to sign, the corresponding y value to that 23, that would have an equal to sign. And that's the range of this linear function. Okay. So this is how we find range of functions. Now, you could write the range in terms of y here. You could also write the range in terms of the function notation. You could say, for instance, in this case, the range of the function is h of x between negative 33 and 23. That's also fine, right? So both of them are acceptable. In the previous cases as well, you had y less than minus 5. That's the same thing as saying you've got g of x less than minus 5. So this represents the y value of the function, right? So both of them are going to be fine. You can use function notation. You can also use y in place of that. Why do we not have an equal to sign with negative 33? Because in the question that they gave, the domain that they gave, they did not have an equal to sign with 5, right? What's the corresponding y value for 5? It's negative 33. So that is also not going to have an equal to sign because this minus 33 corresponds to that 5. Since that is not included, then the y value minus 33 would also not be included. Make sense? All right, so that's for linear functions. All right, I hope that makes sense. If you have any function that does not have any restriction, for example, if you have a function like this, f of x equals 7x plus 3, if it's a function with domain all real numbers, if it's a linear function with domain all real numbers, the range for this function is also going to be all real numbers because this is a straight line. In a straight line, if x does not have any restriction, it's a line like this. That means the whole line is valid, right? You could be anywhere on this line. If x can be any real number, if you can be anywhere on this line, then vertically as well, you can go as low as possible and as high as possible. So the range of this function would also be all real values. So if in a linear function, the domain is all real values, the range is also all real values. Make sense? Is that all right? No problems. Okay, let's move on now. Let's move on and discuss the next kind of function. So this was a linear function, which is relatively straightforward. The most common function that you will be dealing with is a quadratic function. You'll see that again and again in almost every other question in this topic, quadratic functions. And since this will be the most common function that you'll be dealing with, the range of this function would also come the most often that you'll have to find. Let's see how we can find range of quadratic functions now. Okay, let's understand how to find range of quadratic functions. I've written down one function here, f of x equals 2x squared minus 12x plus 24. And the domain of this function is all real values. Okay, so I've got this function. And domain of this function is all real values. What about the range of this function? What about the range of this function? What do you think the range is going to be? Think about it. Let me know in the chat. Everyone, quickly. What should be the range of this function? All real values? No, not all real values. So for linear function, remember it was all real values because it was a straight line function. And in a straight line, you could go as high as possible, as low as possible. So in that case, there was no restriction. So the range was also all real values. But it does not quite work the same way for quadratic functions because remember, what does a quadratic function look like? There are two possible shapes. It could be a U-shaped graph or it could be an N-shaped graph, right? So it could be like this or like this. These are the two possibilities. Which one of the two options is this one? This is a U-shaped graph, right? So it looks like this. It's a U-shaped graph like this. And it has some minimum point. It has a minimum point. So all real values would mean that it could go as low as possible, as high as possible. So there's no maximum limit for this, yes, because in the upwards direction, it could go up to positive infinity. But in the downward direction, there's a limit. There's a lower limit. This function has a minimum point. So the range is not going to be all real values. So how do you find the range of this function then? What you do is you find the turning point first of all. Find the turning point of this function and see what that turns out to be. How do you find turning point of quadratic functions? We've done multiple methods for this. Minus b over 2a, completing the square, differentiation, right? So all of those, any of those methods could work here. Or you could just find it directly from the calculator as well, like we've seen before. Just put this on a calculator, the versions that I recommended. So in this case, go to the equation function, polynomial, degree 2. Just input this function and you get 2 minus 12 and 24. X coordinate of the turning point, that is 3. So this is going to be 3. Y coordinate, 6. So the turning point has these coordinates, 3 and 6. Okay, you could show working in case it was required, minus b over 2a or differentiation. But in this case, you just can do this from your calculator directly. Now, if this is the turning point, let me write that down here. The minimum value, the minimum point of this function, what is that? That's 3 and 6. So what's the range of the function? Range is the set of values of y that this function can have. So vertically, what is the highest point? What is the lowest point? So vertically, you can see the lowest point of this graph is 6. You can be anywhere above that. So 6 is the lowest point. You can be anywhere above that. So you would say the range of this function, therefore, is y greater than or equal to 6. And that's the range of the function. We would also put an equal to sign there because 6 is also possible, right? Or it could be greater than 6. So that's the range of the function. Any questions on this? Any problems with this? Any problems, anyone? No problems? Sure. Okay, good. Let's move on and take a look at another example. Let's do another example. We've got that same function, but now the domain is not all real values. So earlier it was all real values. Now it's the same expression, 2x squared minus 12x plus 24. However, I've changed the domain now. The domain is x less than 2 now. Less than 5, sorry. Domain is x less than 5. Okay. How did we know it was a minimum? Because it was a U-shaped graph. Coefficient of x squared was positive. It was a U-shaped graph. So it was a minimum point, right? Okay. Now, what if the domain was not all real numbers? It was x less than 5. Think about this now. What will be the range of this function? Again, remember the turning point is the same because it's the same expression. I have not changed that. So this U-shaped graph would have the same turning point. But now the domain is x less than 5. Can you think of what the range of this function would be? Any idea? What is the range of this function going to be? Okay, 15 more seconds. Let me know quickly. What should the range be? Okay, so what we can do is we can input x equal to 5 first of all. Let's do that. Let's input x equal to 5 in this function, see what that gives us. X equal to 5. At x equal to 5, we get f of 5, which is equal to 2 into 5 squared minus 12 into 5 plus 24. And this turns out to be 2 into 5 squared minus 12 into 5 plus 24. And that's 14. So we have a point on the graph where x is equal to 5 and y is equal to 14. Now you are saying if x is less than 5, then that means y is less than 14. That's the range of the function going to be. That's what most of you are suggesting. Or at least one part of your range is this, y less than 14. Well, that's not correct. Even those of you are saying it's between 6 and 14, that's also not correct. So how do you think about this then? Let's mark this point on the graph first of all. So it's a U-shaped graph. We know the turning point is at 3, 6, right? Let's mark this point on the diagram, 5 and 14. Where is this point going to be? Is it going to be on the right side of the turning point or on the left side of the turning point? Is it on the right side of the turning point or the left side? On the right side, right? Because at the turning point, x is equal to 3. So let's mark that point. It's going to be somewhere on the right. Let's suppose it's here. And this point is 5 and 14. Okay. Now on the x-axis, what does the domain say? The x value has to be less than 5. So which part of the graph is valid? To the left side of 5. To the left side of 5. That means this part of the graph is what we're talking about, this yellow region. That's the valid part of the graph, right? Everything to the left of 5. So this is the part of the graph that is to the left of 5, right? Now, in this yellow part, what's the lowest point on the graph? In the yellow part, what's the lowest point on the graph? The lowest point on the graph is 6. The y value is 6, right? At the lowest point. What's the highest point on the graph? What's the highest point on the graph? There's no highest point because this part can go up to positive infinity. There's no maximum limit for this. So the range of this function is actually going to be the same as before. It will still be y greater than or equal to 6. This is still y greater than or equal to 6. Okay, because that's what you see on the graph. The lowest point is still 6. The maximum point is still infinity. So the range is still y greater than or equal to 6. Okay. All right. But does it ever change then? So we changed the domain in this case. The range still remained the same. Will it always remain the same? Y greater than or equal to 6? Let's take another example. So you see, all we are changing is the domain of the function. The range, the expression remains the same as before. Now we're saying, let's suppose the domain is x greater than or equal to 4. Right? So now the domain is different. What happens in this case if x is greater than or equal to 4? What will be the range of this function now? So we think of it the same way. We think of the graph of the function. Do not try doing it without the graph. It is possible, but it's very likely to make you do careless errors. So I would suggest that you sketch a graph like this. It's a U-shaped graph. Mark the turning point. The turning point is at 3, 6. And now they're saying the domain is x greater than or equal to 4. Okay, so we're talking about one point which is x equal to 4. You can figure out what the y value at that point is. See what that turns out to be. X equals 4. Input that in the function f of 4. What does that give you? 2 into 4 squared minus 12 into 4 plus 24. What do we get from this? Is it 8? Can somebody confirm that as well? Can others confirm that as well? Yes? Okay, all right. So we've got a point 4, 8. where on the graph does this point lie? To the right of the turning point or to the left of the turning point? On the right side, because the x coordinate 4 is greater than 3. Let's mark this point on the right side somewhere. Let's say it's here. This point is 4 and 8. What's the range of this graph now? What's the range of this function now? What's the range of this function? So x is greater than or equal to 4. So you mark on the graph which part of the graph is valid. To the right side of 4, right? So you have to be to the right of this point, which means this part of the graph is what you're talking about. Now, what about the range of this function? Look at what the lowest point on this yellow part is and what the highest point is. There's no highest point, that's infinity, but the lowest point that you can see on the graph, as far as the y values are concerned, is 8. So the y values can be either equal to 8 or greater than 8. So you would say the range of this function, therefore, is y greater than or equal to 8. And that's your final answer. That's the range of this function. Make sense? Any problems with this? No? Okay, let's look at another one. Now we've got this function. F of x equals 2x squared minus 12x plus 24. The same expression as before. That means the same turning point, U-shaped curve. So for any quadratic function that you get, the first thing you should do is find the turning point. You can use a calculator for that. Draw a sketch, either a U-shape or an N-shape. And then you think about the domain that with using the domain that's given, what the range is going to be. Okay, so figure out what the range of this function is now. Can all of you do this? X is less than 0. That's the domain. What about the range? Again, you've got to think of the graph. Okay, do not do it without the graph. That will make you do errors. You can think of the graph in your head as well. Once you've done enough practice, you probably could do that. But it's still safer to just make a quick sketch, and that will save you from careless errors. So what's the point that we're given in the domain 0, right? X equal to 0. Let's use that point. See what happens when x is equal to 0. See what the y value turns out to be at that point. When x is 0, the y value is 24, right? You input that here, you get 24 from this. 0 and 24. Where is this point going to be with respect to the turning point? It's going to be to the left of the turning point, right? So to the left of the turning point, that is this point here. I'll mark this point. This is 0 and 24. Now they're saying x is less than 0. So which side of this point are we talking about? Less than 0. That will be the left side, right? So this part of the graph is what is valid, right? To the left of this point. What about the y values? If you have to be to the left of this, what about the y values? The y values have to be above this for this yellow part. So the least value was 24. So the range is going to be greater than 24. Do we put an equal to sign with this? No, because 24 is the y value corresponding to an x value of 0. And 0 was not included here. There was no equal to sign with that. So we don't put an equal to sign with 24 here as well. So the range is y greater than 24. That's the range of the function. Okay. So once you make the graph, it becomes fairly straightforward to understand. Let's take another example. Again, the same expression as before. Now the domain is from 0 to 4 like this, with 0 not included and 4 included. So that has an equal to sign there. What you can do is you can find the value of the function when x is equal to 0. So f of 0, that gives you 24. Then you find the value of the function when x is equal to 4. F of 4, we found this earlier as well. F of 4, what was that? 8. So you input those endpoints, find the corresponding y values, see what they turn out to be. So now you mark these 2 points on the graph. The turning point is already marked there. One of these points is going to be to the left of that, the other to the right of that, right? So 0 is on the left side. This point would be 0 and 24, and 4 will be on the right side. So let's suppose this point here is 4 and 8. Okay, what about the range of this function now? We found the 2 points, we marked them on the graph as well. What is the range going to be? What is the range going to be? Okay, just give me a second. I'll be back in a minute. My laptop is just about to turn off. Think about it. Let me know what the range is going to be quickly. Yes, what's the range? 8 to 24, 24 to 6. Well, we can't write it like this. Remember, smaller values on the left side, bigger values on the right side. Is it 8 to 24 or 6 to 24? Again, remember, you have to see the lowest point on the graph and the part that is valid and the highest point on the graph. So what part is valid? Between 0 and 4, between x equal to 0 and x equal to 4. Now, between those 2 points, this is the part that is valid. Now, in this yellow part, what's the lowest point on the graph? The lowest point on the graph is 6, right? And the highest point on the graph is 24. Okay, the lowest point is 6, and the highest point is y equal to 24. So it's going from 6 to 24. So what will be the range that we write there? We will say the range is between 6 and 24. Now, do we put an equal to sign with 24? 24 corresponds to 0. 0 was not included there. So we do not put an equal to sign with 24. Do we put it with 6? Well, 6 is in the middle of that valid part. So 6 will be included. So we do put an equal to sign with 6. So it's going to be y between 6 and 24. 6 on the left side, 24 on the right side. We'll have an equal to sign with 6, but not with 24. That's the range of this function. Does that make sense? Right? Okay, last example. One last example in this. F of x equals 2x squared minus 12x plus 24. x is between -1 and 2. Yeah, it is a bit tricky, but once you make the graph, all you have to think of is what's the lowest point on the graph, what's the highest point on the graph. That's it, right? Mark the part that is valid and see what the lowest point is, what the highest point is. Right? It's all right. It'll start making sense once you are doing some practice, and hopefully in a couple of weeks you should be good with it, inshallah. Okay. All right. Now let's have a look at one last example of this. We've got the same expression. We've got the turning point, that's 3, 6. And now the domain is from -1 to 2. -1 to 2. What about this now? Again, we can calculate the values of y that we get from this. X equals -1. What's the corresponding y value? F of -1. That will be 2 into -1 whole squared minus 12 into -1 plus 24. And that gives us 14 plus 24, which is 38. Right? That's 1 point, -1 and 38. And the other one, x equals 2. Input that in this function, and that gives you 2 into 2 squared minus 12 into 2 plus 24. What's this? 32 minus 24, which is 8. Yeah, okay. Thank you. So again, we think of the graph. Which side of the turning point are these points going to be? -1 is on the left side, 2 is also on the left side. So -1 is going to be further on the left. So let's suppose this point here, this is -1 and 38. And the other one is on the right side somewhere, maybe here, as in closer to the turning point. That's 2 and 8. Now, what part of this graph is valid? The part between -1 and 2, that will be this part here. Okay, that's this part here. Now, in this part, what's the lowest point? What's the highest point? Now, the turning point is not in the given domain, right? It's outside the domain. So the lowest point now is 8, the highest is 38. So you could say the range of the graph, therefore, is y between 8 and 38. Now, they had an equal to sign with 2. 2 corresponds to 8. So you have an equal to sign with 8 here and not with 38. And that's what the range is going to be. Okay. These are all the different cases that you can have with quadratic functions, the range of quadratic functions. I hope that makes sense. Now, notice something that we did while finding the range of these functions. We looked at two kinds of points. Number one was the endpoints of the domain. So in this case, for example, the domain is from -1 to 2. So we looked at what happens at -1, we looked at what happens at 2. In the earlier cases as well, we looked at what happens at the endpoints, at what happens at 0, what happens at 4, and so on. So we look at the endpoints of the domain that is given. That's one point that we always look at. And then we also look at what happens at the turning point of the graph, right? And this is a general thing that you'll now keep in mind for finding the range of any other functions as well. In the next class, for example, we will see how to find the range of reciprocal functions where you have x in the denominator and trigonometric functions, sine, cos, tan. This will be common in all of them, that there are two kinds of points that we look at. Let me write that down. When finding the range of any function, when finding the range of any function, there are two kinds of points we always consider number one, the endpoints of the domain. So you'll have the domain given. You will see what happens at the endpoints. Endpoints of the domain. And number two, any turning points on the graph. There could be multiple turning points as well in case of other functions. If they are within the given domain. For example, in the last example that we saw here, the turning point was outside the domain. It was not inside the domain, right? The domain was from -1 to 2. Even though we still had to find the turning point to check if it falls inside or outside. In this case, the turning point was outside the domain. Since it was outside the domain, we say that is not going to be considered in the range, because the range now in this case was just 8 to 38. We did not use 6 there. But when it does fall in the interval, when it does fall in the domain, like in this case, the turning point was within the domain, then you have to consider the turning point as well. So there are two types of points that you will always consider when finding range of functions: endpoints of the domain and the turning points of the function. Okay, you'll see this pattern in the other kinds of functions that we will discuss in the next couple of classes as well now, inshallah. Okay. Yes, we will, of course, talk about inverse functions as well, but that will be next week. Next week, most likely in the second class that we have on Wednesday, inshallah. For next class in particular, I'm thinking of doing range of reciprocal functions and also trigonometric functions, inshallah. All right. So that's the plan for the next week, inshallah. Now, for now, you will not be able to do a lot of questions on functions. It's a big topic. We need to be able to do a number of concepts before you can start doing some questions. I'll upload the worksheet nevertheless. You can have a look at that. But next week onward, you will be able to start attempting some questions from that. Okay, there are quite a few concepts that we have to cover in this topic that we will be doing over the next couple of weeks, inshallah. For P3, you can start with the integration worksheet. I haven't uploaded that yet, but I'll upload that hopefully in an hour at max. I will try that I can mark some questions that you can do until this point. We have done a few concepts in today's class because of based on which you will be able to attempt some of the questions from the worksheet. I'll mark those questions. You can start working on that. Hopefully, I'll do that in an hour or so, inshallah. Okay. Now, for the next class, even though you can't do many questions on functions, I would recommend that you revise what we have done today. Okay, just revise what we've done today. It wasn't much, but it was a bit tricky, especially quadratic functions. So we talked about function notation. Then we talked about what domain and range of a function are. Domain is set of values of x, range is set of values of y. The two conditions for domain that you need to remember: inside a square root, you cannot have something negative. If you have a fraction in the denominator, you cannot have a 0. Then for range, we talked about how to find range of linear functions and then quadratic functions. We'll continue from here in the next class, inshallah, when we talk about range of reciprocal functions and trigonometric functions. All right, that's it for today. I'll see you again in the next class. Allah Hafiz. Those of you on paper 3 as well, I'll upload the worksheet tonight, inshallah. Okay? All right, Allah Hafiz.